Hello everyone, this is Dr. Aparna, Associate Professor and Head of the Department of Mathematics and Management Sciences. Today I am going to explain the applications of partial differentiation and related problems. Partial differentiation is the mathematical process of finding the rate of change of multivariable function with respect to one variable while keeping all other variables are constant. It is a fundamental in modeling real-world systems where outcomes depends on several factors. Now, I will explain the definition of partial derivative. The definition of partial derivative is, let assume that z is a form of function of x comma y. Let assume that z is equal to f of x comma y be a function of two variables x and y. Then limit x tends to 0, f of x plus delta x comma y minus f of x comma y divided by delta x, if it exists, is said to be partial derivative of f with respect to x, and it is denoted by dou f by dou x. Similarly, partial derivative of f with respect to y is denoted by dou f by dou y. Therefore, dou f by dou y is equal to limit y tends to 0, f of x comma y plus delta y minus f of x comma y divided by delta y. If this right hand side limit exists, then this is denoted by dou f by dou y. Dou f by dou y is nothing but partial derivative of f with respect to y. Dou f by dou x comma dou f by dou y are known as partial derivatives of first order partial derivatives of f with respect to x and y. Similarly, dou square f by dou x square, dou square f by dou y square, dou square f by dou x dou y, dou square f by dou y square, dou square f by dou y dou x are known as second order partial derivatives of f with respect to x and y. Second order partial derivatives of f with respect to x and y. Therefore, dou square f by dou x square, dou square f by dou y square, dou square f by dou x dou y, dou square f by dou y dou x are called second order partial derivatives of f with respect to x and y. Coming to the higher order partial derivatives, dou square f by dou x square, dou square f by dou y square, dou square f by dou x dou y, dou square f by dou y dou x. These all are known as higher order partial derivatives, especially we can call it as second order partial derivatives of f with respect to x and y. Third order partial derivatives of f is denoted by dou cube f by dou x cube, dou cube f by dou y cube, dou cube f by dou x square dou y, dou cube f by dou x dou y square. These all are called third order partial derivatives of f with respect to x and y. Now, I will explain some of the problems related to how to calculate the partial derivatives of the given function with respect to x and y. The first question is, find first and second order partial derivatives of the function x cube plus y cube minus 3axy. So here we are going to calculate the first and second order partial derivatives of the function x cube plus y cube minus 3axy. Here assume that f is equal to x cube plus y cube minus 3axy. The given function is denoted by f, let us say. Differentiating f partially with respect to x will get dou f by dou x. Therefore, dou f by dou x is equal to dou by dou x of f is x cube plus y cube minus 3axy. When you are differentiating f with respect to x, first of all we are going to differentiate x cube with respect to x partially. When you are differentiating partially with respect to x, treating y terms are constant. So, this can be written as dou by dou x of x cube plus dou by dou x of y cube minus, here 3a is constant, dou by dou x of xy. When you are differentiating partially with respect to x, dou by dou x of x cube, that is nothing but derivative of x cube with respect to x partially, that is nothing but 3x square, plus when you are differentiating the second term with respect to x partially by treating y constant, this value will be equal to 0. Derivative of a constant term with respect to x is 0, minus here 3a is constant into differentiation of xy term with respect to x by treating y is constant is, by taking constant term y, taking common out, you will get dou by dou x of x. That is equal to 3x square minus 3ay into dou x by dou x value will be equal to 1. Finally, we will get 3x square minus 3ay. Therefore, finally, dou f by dou x value will be equal to 3x square minus 3ay. Next, we are going to calculate dou f by dou y. Dou f by dou y is nothing but derivative of f with respect to y partially. That is equal to dou by dou y of, what is f here? X cube plus y cube minus 3axy. So, derivation of x cube with respect to y partially, that value will be equal to 0, because derivation of x cube with respect to y by treating x is constant. When you are differentiating partially with respect to y, treating x terms are constant. So, derivation of x cube with respect to y value 0. Derivation of y cube with respect to y is denoted by dou y of y cube. When you are differentiating with respect to y, here in the third term 3ax is constant. The remaining expression can be written as dou by dou y of y. That is equal to derivation of y cube with respect to y is 3y square minus 3ax into dou y by dou y, that is 1. So this is equal to 3y square minus 3ax. Therefore, the first order partial derivatives of f with respect to x and y is denoted by dou f by dou x and dou f by dou y. This is dou f by dou y. Already we calculated dou f by dou x in the previous stage. Now we are going to calculate second order partial derivatives of f. The second order partial derivatives of f is the second order partial derivatives of f is denoted by dou square f by dou x square, comma, dou square f by dou y square, comma, dou square f by dou x dou y, comma, dou square f by dou y dou x. These all are called second order partial derivatives of f. Now we are going to calculate that values. Now coming to this one, given that f is equal to x cube plus y cube minus 3axy. So already we calculated dou f by dou x is 3x square minus 3ay. Dou f by dou y is 3y square minus 3ax. Next we are going to calculate dou square f by dou x square. Dou square f by dou x square is equal to dou by dou x of dou f by dou x. That is equal to dou by dou x of, what is dou f by dou x here? Here already we calculate dou f by dou x. Here dou f by dou x value is 3x square minus 3ay. 3x square minus 3ay. Now, when you are differentiating this expression we have, this can be written as dou by dou x of 3x square minus dou by dou x of 3ay. This value will be equal to 3 is constant. Derivative of x square with respect to x partially is 2x. Minus, in the second term, when you are differentiating with respect to x, 3ay term is constant. Derivative of 3ay is 0. So you will get 3 into 2 is 6 into x, 6x. Dou square f by dou x square is equal to 6x. Similarly, dou square f by dou y square is equal to, can be calculated, dou by dou y of dou f by dou y. That is equal to dou by dou y of, what is dou f by dou y here? Here dou f by dou y is 3y square minus 3ax. 3y square minus 3ax. When you are differentiating with respect to y partially, derivation of 3y square with respect to y is 3 into y square derivative is 2y. When you are differentiating 3ax with respect to y is 0. That is 6y. Next, dou square f by dou x dou y. Next we are going to calculate dou square f by dou x dou y. That is equal to dou by dou x of dou f by dou y. That is equal to dou by dou x of, what is dou f by dou y? From the previous step, we know that dou f by dou y value is 3y square minus 3ax. 3y square minus 3ax. That is equal to differentiation of 3y square with respect to x partially is 0. Minus, when you are differentiating partially with respect to x, 3a is constant into derivation of x with respect to x is 1. That is minus 3a. Dou square f by dou x dou y value is minus 3a. Next, I am going to calculate dou square f by dou y dou x. That is equal to dou by dou y of dou f by dou x, that is equal to dou by dou y of, from the previous step we know that dou f by dou x value is equal to 3x square minus 3ay. 3x square minus 3ay. When you are differentiating, the first term with respect to y will get 0 minus, in the second term 3a is constant, into derivation of y with respect to y is 1, that is minus 3a. Therefore, dou square f by dou x dou y is also same as dou square f by dou y dou x. That value will be equal to minus 3a. So, the first order partial derivatives of f with respect to x and y is denoted by dou f by dou x and dou f by dou y. Second order partial derivatives of f is given by dou square f by dou x square, dou square f by dou x dou y, dou square f by dou x dou y, dou square f by dou y dou x. These all are called the second order partial derivatives of f. Next I am going to explain the second problem. Second problem is, if u is equal to tan inverse of 2xy divided by x square minus y square, tan inverse of 2xy divided by x square minus y square, comma, prove that dou square u by dou x square plus dou square u by dou y square is equal to 0. Prove that dou square u by dou x square plus dou square u by dou y square is equal to 0. So, for proving this result, first of all we are going to calculate the partial derivatives of u with respect to x. Given that u is equal to here tan inverse of 2xy divided by x square minus y square. Now, differentiate u with respect to x partially. We have dou u by dou x is equal to dou by dou x of tan inverse 2xy divided by x square minus y square. So, this value will be equal to, already we know that d by dx of tan inverse x is equal to 1 by 1 plus x square. So, when you are differentiating tan inverse x with respect to x, we will get 1 by tan inverse x derivative is 1 by 1 plus x. We can apply that formula. We have 1 by 1 plus, in place of x we have 2x by y, x square minus y square term is there. So, that is 2xy by x square minus y square whole square. One derivative of tan inverse x is of the form, this expression is of the form d by dx of tan inverse x type. Tan inverse x derivative is 1 by 1 plus x square. So, by applying that definition, we will get dou by dou x of tan inverse 2xy by x square minus y square is equal to 1 by 1 plus x square into 1 by 1 plus 2xy by x square minus y square whole square into dou by dou x of 2xy by x square minus y square. So, this is equal to, when you are simplifying this expression, we have this is equal to 1 by 4. When you are squaring of the second term, 4x square y square divided by x square minus y square whole square into, this is of the form d by dx of u by v type. d by dx of u by v is equal to v into derivation of u minus u into derivation of v by v square. So, this expression is of the form dou by dou x of u by v type. So, dou by dou x of u by v is equal to v into derivation of u minus u into derivation of v by v square. Now, applying that definition, we have this value will be equal to dou u by dou x is equal to 1 by 1 plus 4x square y square divided by x square minus y square whole square into d by dx of u by v form is u into dou v, u into derivation of v with respect to x, v into derivation of u with respect to x minus u into derivation of v with respect to x by v square. D by dx of u by v is equal to v into derivation of u with respect to x minus u into derivation of v with respect to x by v square. This is equal to 1 by 1 plus 4x square y square divided by x square minus y square whole square into, here what is u? In the previous step, numerator term is u, this is 2xy is u and v is x square minus y square. U is 2xy, v is equal to x square minus y square. So, v is x square minus y square into dou by dou x of u is 2xy minus u into, what is u here? 2xy into dou by dou x of, what is v? Here v is x square minus y square divided by v square. V is equal to x square minus y square whole square. So, after that this value will be equal to 1 by 1 plus 4x square y square divided by x square minus y square whole square into, numerator term is x square minus y square into derivation of 2xy with respect to x is 2y, partial derivative. 2xy into dou by dou x of x square minus y square derivative is 2x by x square minus y square whole square. So, after that, taking the LCM of this expression and then simplifying, finally we will get dou u by dou x is minus 2y by x square plus y square. After simplifying, you will get dou u by dou x value is minus 2y by x square plus y square. Next, I am going to calculate dou square u by dou y x square. Next, I am going to calculate dou square u by dou x square, that is equal to dou by dou x of dou u by dou x, that is equal to dou by dou x of, in the previous step we know that dou u by dou x value will be equal to minus 2y by x square plus y square. So, replace here minus 2y by x square plus y square. When you are differentiating partially with respect to x, minus 2y term is constant into dou by dou y of 1 by x square plus y square. So, this value will be equal to, after that when you are differentiating you will get minus 2y by, this is of the form, this is dou by dou x of 1 by 1 x square plus y square. When you are differentiating this term with respect to x, this is of the form 1 by x type. Derivative of 1 by x is equal to minus 1 by x square. So, you will get minus 1 by x square plus y square whole square into derivation of x square plus y square with respect to x is 2x. So, finally, we will get minus of minus is plus, 2 into 2 is 4, 4xy by x square plus y square whole square. Therefore, finally, dou square u by dou x square value will be equal to plus 4xy by x square plus y square whole square. Similarly, we will get dou square u by dou y square will be equal to again minus 4xy by x square plus y square whole square. By applying the same procedure, simplifying, you will get dou square u by dou y square is equal to minus 4x by y by x square plus y square whole square. Therefore, adding equation A and b we have, by adding equation a and b we have a plus b is equal to dou square u by dou x square plus dou square u by dou y square is equal to plus 4xy by x square plus y square whole square minus 4xy by x square minus y square, x square plus y square whole square. When you are adding these two terms gets cancelled, finally that value will be equal to 0. Therefore, finally, dou square u by dou x square plus dou square u by dou y square is equal to 0. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.